Welcome to the Living to 100 Club podcast. Here's our host, Dr. Joseph Casciani.
Welcome to the Living to 100 Club, where we explore what it really means to live longer and better. I'm Dr. Joe Casciani, a geropsychologist focused on the mindset, habits, and science of aging well. Each episode brings you practical ideas and conversations to help you stay engaged, resilient, and purposeful at any age. And now to today's program. In this return visit to our podcast, I welcome back biochemist and researcher Dr. Joel Brind for an updated conversation on the growing interest in glycine and its potential role in healthy aging. Building on our earlier discussion, Dr. Brind will explain in clear, everyday language why chronic inflammation may be connected to many of today's most common health concerns, including insulin resistance, metabolic disorders, cognitive decline, and reduced vitality with aging. Before we begin, let me give you a little background. Dr. Joel Brind is a biochemist with a PhD in biochemistry, physiology, and immunology, and he's a recognized expert in amino acid metabolism and its impact on health. Over his distinguished career, he has focused on the critical role of glycine in regulating inflammation and preventing chronic diseases. His groundbreaking research highlights glycine potential to address conditions like metabolic syndrome, cardiovascular disease, and neurodegenerative disorders. In 2010, Dr. Brind founded Natural Food Science, LLC, where he developed Sweetamine, a unique supplement leveraging glycine's anti-inflammatory properties to promote better health and wellness. Through his innovative work and dedication to scientific discovery, Dr. Brind continues to provide actionable insights into the connections between diet, biochemistry, and long-term health. Dr. Brind, welcome back to our program.
Thank you very much. Good to be here again with you.
Oh, you're welcome. Looking forward to our follow-up. So, for many listeners who may have missed our earlier conversation, can you briefly explain what glycine is and why it's become such an important focus of your research?
Oh, it is the simplest of all the amino acids. There are approximately 20. There are actually a couple more odd ones, but they're basically 20 amino acids, which are the different Lego blocks, if you will, from which all the various proteins are made in our body. And glycine's probably the most abundant or the second most abundant in the body, and it's also considered non-essential because your body can make it. Basically, your liver and some other cells can make it from simpler compounds, which is in a way a kiss of death as far as research is concerned, because who's going to research something that's non-essential? We all found out that the word non-essential is toxic, right? During COVID, we all learned that. And so glycine is the very simplest one. And it also has other roles in the body, quite a few other roles in the body, besides being one of the building blocks of protein, because it's so simple, it's so fundamental. It's one of the molecular components, or it's used to make molecular components for DNA, for neurotransmitters, for hormones, for lots of different things in the body. And one particular function in the body, which is actually not a biochemical function, is it functions as a regulator of cellular physiology in the immune system. How? By being present in relatively high concentrations, it is the gatekeeper of a molecular switch, which is called a chloride channel, a glycine-gated chloride channel. It literally opens or closes the channel, allowing chloride ions to flow in or out of the cell. Well, so what? Well, what does that mean? The cells which cause inflammation, which we now hear so much about because inflammation is the basis or the bedrock, if you will, of so many different conditions, so many chronic disease conditions, that most of the things that make us sick and die these days, actually, are grounded in chronic inflammation. And everybody knows that in the research world. Everybody has acknowledged that. That's where all the research points to. And it works in that regard as a switch. The cells that cause inflammation are called macrophages. And the switch is like every switch that turns cells on and off is just like the electrical switch on the wall that may turn the light on and off.
Sure.
It's an electrochemical switch, if you will. And when you have a switch, you have two poles in the switch, right? And when the switch is opened, when the light is turned off, the poles are separated from each other, and one of them has a voltage on it, like 120 volts, and the voltage of the other one is zero.
Yeah.
So the switch is polarized, right? 120 volts is the potential, electrical potential between them. When you turn the switch on, right, you close the switch. Now there is no polarization. The voltage between them is not 120,
Mm.
it's zero. And that activates the switch to go on. Well, activities in cells work pretty much the same way.
Mm.
And ordinarily, the polarization of the cell is there is a negative voltage inside relative to outside. It's not 120 volts. Unless you're an electric eel, you have voltages like that. But in our ordinary physiological experience, we have about 0.07 volts, about 70 millivolts is what the voltage is. And in the ordinary activities of the cell, especially macrophages, which whenever there is cellular injury, cell death, damage, they have to come around and clean up the mess. And they're all like little amoebas, phagocytosing,
Mm.
engulfing the particles of cells and cell debris. And as they do that, things leak out and things leak in. And so that voltage may deteriorate. And if the voltage deteriorates too much, guess what? The cell gets activated to what's called an M1 level,
Mhm.
macrophage 1, as opposed to macrophage 2, which is basically cleaning up the mess. Macrophage 1 is now causing inflammation. It starts
Mhm.
a whole cascade of secreting poisons, which will also damage normal tissue, in addition to killing whatever microbe got in before it kills you. But it's not supposed to do that. And
Mm.
glycine, in very high concentrations, not as a biochemical in a sense, because it is not being transformed into something else. Glycine is not being used to make something else. It's basically at a certain concentration, keeping those gates open, allowing chloride ions, which are negatively charged ions, to enter the cell, and that keeps the voltage up so that the cell does not get polarized, doesn't get depolarized,
Mhm.
and start the chain of events of inflammation. Now, what the key discovery, the key scientific breakthrough here, and there is one that is more key than anything else, is that the commonly accepted definition of inflammation is actually wrong because it's a half-truth. If you look at any source of medical information. You can go to Wikipedia or WebMD or any physiology textbook that you like,
Mhm.
or any immunology textbook that you like, or medical textbook. It will say that that inflammation is uh, the body's or the immune system's first response to
Mhm.
infection or injury.
Mm.
That is a half-truth. It is not the natural first response to injury, only to infection. Why do we say that it's a first response to injury? Because that's what always happens. That's everybody's experience.
Uh-huh.
But it actually is inappropriate, and all it does is damage normal tissue and create chronic damage, chronic dysfunction, which leads to all kinds of problems down the road, including ordinary aches and pains.
So it
So
contributes to infection. And I mean,
So,
it's a
but
response. It's a response.
infection, you need that
Response.
because you got to kill that bug before it kills you
Yeah.
if that's what's happened. That's why your immune system needs to be able to do that. But because of the general situation in the population around the world, most people are deficient in glycine.
Mm.
So it's actually not non-essential. That's the corollary, really, to that initial
Mm.
discovery,
Okay.
to that principal discovery of it not being appropriate to deploy inflammation in the case of injury. The corollary really is that we tend to be deficient, that we don't ordinarily get enough to maintain that integrity of the immune system so that it doesn't cause inflammation. So an
Mm-hmm.
ordinary diet will give you enough glycine because your body can make it.
Mm-hmm.
What your body can make and what you ordinarily eat 2 to 3 grams a day of glycine in the various proteins that you eat. But you need about 10 grams a day to
Mm-hmm.
maintain that function in the immune system to prevent inappropriate inflammation. So in that sense, let's say, many researchers are now currently coming to view glycine as conditionally essential.
Mm-hmm.
And so that's really the corollary, is that it's not non-essential after all, because it has this other important function
Mm-hmm.
that's been overlooked and for which it's needed in much higher concentrations.
So that's the reason it's on the spotlight is on glycine. The shortage contributes to chronic inflammation, more or less.
Well, the shortage, if it stays that way,
Mm-hmm.
because glycine, what's not chronic is the concentration of glycine. It's a small molecule, a water-soluble molecule. It cycles through you very quickly. Its biological half-life is measured in hours, not days. And so, you take, let's say, like the glycine supplement that I sell, the
Mm-hmm.
Sweetamine. If you take Sweetamine, you start taking it, and by the third day, by the second or third or fourth day, you feel, usually, if you're feeling chronic inflammation because you have aches and pains and so on, you will feel them go away in 2 or 3 days. And
Mm-hmm.
you say, "Wow, this is great," but I don't know. Is that really what's doing it? I'm not so sure. And then you go off it. 2, 3 days later, sure enough, the pain
Yeah.
comes back. And
Yeah.
so, I encourage people to experiment on themselves because glycine
Sure.
is very, very safe. It's probably safer to ingest than water. I think it's virtually impossible to drink enough glycine solution at any strength to actually do yourself any harm. The closest that they've come to an LD50 for a lethal concentration of glycine,
Mm-hmm.
it's something like 5 grams per kilogram. So for an ordinary 70-kilogram man like me, I weigh 75 kilograms, right? So, what's 5 milligrams per kilogram? It's about 35 grams a
35
day,
grams.
35 grams a day. That's about an ounce and a half of dry powder. I
Mm-hmm.
mean, you'd have to take a tremendous amount.
It's a lot.
Um, let's see. No, I'm sorry, 350 grams. It's sort of like 12, you'd have to
Oh,
take 12
that's
ounces
huge.
of dry powder,
That's
to kill yourself.
yeah.
You couldn't do
Yeah.
it.
So for the non-medical members of the audience here, including myself, why is chronic inflammation the root of so many health problems? So many.
Well, because as I mentioned, the when inflammation it's a secretion of poisons. The immune system is now secreting poisons
Hmm.
to try and poison something. It's like chemotherapy, it's throwing a lot of heavy poison at something, some bug that got into you to kill it before it kills you, because
Hmm.
bacteria and viruses and mold and so forth, they can multiply very rapidly, even from very small doses, like whenever there's when there's some sort of a crisis in food contamination, right? Where there's like salmonella poisoning. When you have salmonella getting into the food supply and they recall batches of some kind of food or other, and hundreds of people or thousands of people can get sick, and very often, and some number of people will die from it, because if there, just a few bugs, like a dozen or 2 dozen salmonella bacteria, which are
Hmm.
tiny,
Hmm.
tiny, tiny fractions of the size of a single human cell, if they get in, they can actually cause a lethal infection. So
Hmm.
it's very, very important for your body to be able to get these things right at the source and
Hmm.
really throw some very heavy chemical poison at it. But when you're doing that from activation that's inappropriate, just from ordinary injury. And when I say injury, I mean even micro injuries, like from things like blood circulation.
Hmm.
Blood circulation in your arteries, it's a very high pressure fluid situation. So especially at branch points, like where your coronary arteries branch off from your systemic aorta right outside the heart, carotid arteries, the renal arteries, these
Mm,
high pressure arterial branch points always generate turbulence, especially with things like exercise, you know.
mm,
So well, turbulence is going to cause micro damage. You know,
uh,
it'll cause damage or death to a few cells around the branch point. It'll damage slightly the lining of the blood vessels. Well, so what? Your body's very resilient. A little bit of damage heals it right up, no problem, unless you're deficient in glycine. And
mm,
then you get cells that come around and cause inflammation. And
uh,
then when your body tries to repair itself through the inflammation, think about it. You have a blood vessel that's got to be an opening on the inside. And then when you get a little hole in it, a little tear in it, what happens? The body tries to repair it, putting
mm,
a patch on it and another patch over the patch. And you get sort of scar tissue or the equivalent inside an artery would be an arterial plaque. It's basically like scar tissue inside the artery. And eventually it builds up and it clogs it
mm,
narrows the diameter of the artery. So you get atherosclerosis.
mm.
And so atherosclerosis will happen. Basically, a little pop-up came on my computer. I had to clear it.
Sure,
I have no idea whether you
sure.
saw it. But anyway, atherosclerosis then is what happens mostly in those arteries where they are at high pressure branch points.
Mm,
And so when you get a blood clot, an inappropriate clot, or when the blockage just gets so much that it clogs up and compromises the blood supply enough to the heart itself, you can get a heart attack. To the brain, you can get a stroke. To the
mm.
kidneys, you can get malignant hypertension
Well,
from these arteries getting clogged up. So that's one way it can happen. Other ways is that when you have inflammation, all these poisons around, they tend to stimulate the development of cancer cells.
uh,
So, for example, one of the earliest epidemiological cancer associations observed was, oh, maybe 50 years ago, that in the case of ovarian cancer, women who get ovarian cancer are more likely to have ovulated more times in their fertile years.
mm,
And because every time a woman ovulates from alternately one ovary and then the
mm,
other ovary alternating month to month, you get an ovulation. What's an ovulation? That's where the ovary releases an egg so that it's then possible to become fertilized. However, that sounds very benign. The ovary releases an egg. Yeah, it releases an egg like a shotgun releases
uh,
a bunch of
mm. That's
buckshot,
the
or a
turbulence.
volcano releases
Uh,
some magma, in the form of
uh,
lava,
sure.
and so this is a very, very violent process. Well, it only happens once every other month in each ovary, and it repairs itself. No big
Hmm.
deal, unless you have chronic inflammation, unless it gets inflamed because you're chronically deficient in glycine.
Oh,
So there are many processes like this
mm,
which cause naturally, part of the natural cycle of things, there is injury, there is cell death. The natural cycle of the rise and fall, for example, of tissue in the breasts. When every reproductive cycle, it's not only ovulation, but when that happens, there's also breast tissue that is multiplying
mm,
to be able to produce enough milk to feed a baby when it's born. That happens during the menstrual cycle, right? About the third week of the menstrual cycle. But if conception does not happen, all those extra cells, they have to die off.
hmm.
No big deal. They die off. It's natural. What's the big deal? Well, the big deal is that if you're glycine deficient, you get inflammation month after month after month. So breast cancer is related very directly, epidemiologically, statistically, to how many menstrual cycles you have had during your fertile years, if you're a
Oh,
woman, obviously.
mm,
So all of these things can be, the epidemiology is the statistical footprint, the way you can track
yeah.
these events that happen. And these all correlate very well with inflammation. And the other kind of epidemiology that you can see reflected so well in this particular area is where you look at a bunch of people with heart disease, a bunch of people with cancer, a bunch of people with diabetes, and you
Mm,
look at glycine levels, and
mm,
you see, aha. Glycine levels are lower in people with diabetes, lower in people with
Oh,
heart disease, lower in people who are obese, lower in diabetics,
yeah.
right? All of these conditions which are related to chronic inflammation, all related to glycine
Yeah.
deficiency. And we
Yeah.
know very directly, as I explained before, the molecular events by which glycine prevents inflammation from
Hmm.
happening appropriately.
Yeah. I was
So
going to
it's a
ask
pretty
that.
simple story. And in
It's,
fact, I love it because it's one of the most simple stories. So
yeah.
many things are very confusing because, they seem to be very complicated. But of
Oh,
course, the light really goes on, when everything becomes simple. Like if you're doing a jigsaw
yeah.
puzzle, you
Right.
finally find that one piece that seems to fit the picture, and then all of a
Mhm.
sudden, every other piece of the puzzle. I
Oh,
mean, when I first discovered these things in like 2008,
oh,
2009,
yeah.
2010,
Yeah.
around there, a new research would come out, or I would discover some older research and some of
Mm,
my own research that I was
mm,
doing with rats and
mm,
mice, would again, rats and mice live longer when you supplement their diet with
mm.
glycine, you know,
Yeah.
among
All,
other things.
all the
So you
puzzle
can treat with
pieces,
glycine.
started fitting
Yeah, all
together.
the pieces started coming together, and when it's right because
Yeah.
no matter what happens, what kind of research is thrown at it, it's not you don't get the apple cart upended, because if that's what
Yeah.
you may think you're onto something in research. Research is a very frustrating business. It's not for everybody because I would say most, as I told the technician once who was having great difficulty working in the lab, I don't think he stayed on in medical research because he was too easily frustrated. I said, trying to console him after some experiment had failed. I said, in medical research, I said, most experiments fail.
Mm,
They really do. They don't, they
mm,
don't necessarily show you what you want.
mm,
Sometimes you get in a groove where they do, once have a finding that's real, and then you can do a whole bunch of confirmatory studies. Well, let's see if it does it when you do this. Let's see if it does it when you do
uh,
that. What if we change the conditions
yeah.
this way, or we use something else that's similar, or so that systematically, then you can do a series of experiments one after
Sure.
another that work
Yeah.
because you're
Change the
really
variables a bit.
confirming
Yeah.
something that you
Mm,
found that's real. But if it's not real, if your
mm,
hypothesis has some holes in it, you're
mm,
going to run into experiments that don't work. They
yeah.
don't
Yeah.
they don't show you what you think they do. And this is another problem with research is that many people run experiments and the experiment will work. It will give you the kind of result that you expected, but it won't be what you think it was.
Hmm.
So we ran into a little bit of this also. I mean, yeah, we
Hmm.
were we were working on um, a phenomenon called methionine restriction, which is if you take rats or mice and you feed them an amount of or a diet containing an amount of the essential amino acid methionine that's almost inadequate, almost deficient in methionine. You still allow them to eat as much as you want, but the diet is almost deficient in its methionine content. Then the rats won't grow normally, but they're still sort of happy and active,
Hmm.
and they'll live 30 or 40% longer. So this is now known, it's been reproduced many times as the aging phenomenon called methionine restriction,
Wow. Yeah.
dietary methionine restriction. And so
Yeah.
because it had just been established that glycine is the substrate or the material that is used by the liver to get rid of excess methionine,
Mm,
um, then we thought, well, if we supplement with methionine, maybe that'll make them live longer. And guess what? It
mm,
did. Oh,
mm,
yes.
mm,
Glycine mimics, methionine by helping to clear methionine out of the system. So it mimics
yeah.
methionine restriction. Well, it turned out that wasn't true. It didn't do that
Mm,
because when you looked at the data, guess what? It didn't change the amount of methionine in these animals' blood or in their liver.
mm,
Amount of methionine was the same. So adding more glycine didn't help them get rid of methionine, was doing something else.
yeah.
What we
Wow.
found out was, of course, that it was the methionine all along that was stripping the glycine. And
Mm,
the glycine was not that sort of, oh, well, that sort of unimportant, non-essential amino acid that the liver uses to dump excess methionine on.
mm,
It was very important itself
mm.
in health and disease and
Yeah.
longevity in these animals. You can do longevity studies when animals live only 3 or 4 years anyway, right?
It
So,
was really the magic pill, so to speak.
It's
It's
magic
like
in
the
some ways,
glycine
yes.
deficiency seems to be affecting so many areas
Right.
of functioning in our body. And let's talk about brain health a little bit and how
Brain health,
the
yes.
connection there, memory and
Mhm.
cognitive functioning, even mood. How does that come into the picture?
Well, in a couple of different ways. I think neurodegeneration with age is also ascribed to inflammation,
Hmm.
Parkinson's disease. I mean, I guess famous case, Muhammad Ali, right? Like many other boxers, had his brains bashed in many times.
Hmm.
Fewer than most because he was such a good boxer, but
Oh,
he ended up with Parkinson's disease, and
sure.
I don't think anybody would argue that that's why he got Parkinson's disease
Hmm.
because he was a
Hmm.
boxer,
Hmm.
and when you get knocked out by guys like
Yeah.
Sonny Liston, it's going to do some
Yeah.
damage.
We used to call
Well,
that dementia pugilistica, if you remember that.
right. So there's
Getting the head blown around so many times with
right,
punches.
and so dementia is also associated with Parkinson's
Of
disease,
course,
really different parts of the brain
of
that,
course. Yeah,
will
yeah,
affect different, whether it's cognition or, motor skills, that kind of thing.
mm,
Well, so a lot of my research life had to do with self-experimentation, some of it unintentional.
mm,
So once I was onto this and I started taking glycine 10 grams a day. Now I take about 8 grams a day. That's the way I package the formulation, is to take 8 grams of supplemental glycine every day as sweetamine. But now that I was doing it, I have not been glycine deficient now for 15 years
yeah,
or 18 years, about.
yeah,
So one time about 8 years ago, I had just had a long drive and I didn't have any water on the trip. It was like a 3 or 4 hour drive. And when I got to this is my kid's house. And when I got there, I sat down, relaxed with a nice glass of wine, but I didn't have a glass of water. So I was dehydrated.
mm,
And then when I got up a few minutes later, I was a little lightheaded, enough so that I blacked out just for a second. It was enough
yeah.
to go wham,
Wow.
right down on the sharp edge of a hardwood table. And the next thing I knew, I was on the kitchen floor looking
Mm,
up.
mm,
And I see there are my kids there, and I'm confused. They say, who are we? Oh yeah, I know you, and I know you, and what about Sweetamine? And I'd say, Sweetamine, that's a nice name. What's that? And it was like, uh-oh, because
wow.
that's my product, right?
Of course. Yeah,
If I'm confused about that, I'm in bad
yeah,
shape.
yeah.
So the confusion lasted some number of seconds, till I kind of came to. It was like the old Western movies where the bank robber comes in and clocks the guard
Mm,
on the head with the butt of his
mm,
pistol. And so I was out momentarily, and then so they wisely called the 911, and they came over and they took me to the ER and the ambulance and all of that, and I got to the hospital. They did their evaluation, and of course my head hurt. Well, after about 2 hours or so, because you have to wait for all kinds of things to happen, of
sure.
course. And after about 2 hours, my head didn't hurt anymore, and the confusion had long since dissipated. And they said, well, you had a concussion. You were confused,
Mhm.
unconscious briefly. You had a serious concussion, and you really ought to follow it up. I said, that's fine. I'll be fine. I'm
Mm,
okay now. I don't worry about it. And I didn't worry about it, and I don't worry about it. That was, as I said, that was 8 years ago, and I never had any kind of sequelae to that.
mhm.
Nothing,
Good,
nothing
good.
ever bothered me again as far as,
Mm,
in my head or my brain or anything like that. So I'm convinced also that, chronic traumatic, what is it, CTE they call it? Chronic
Chronic
traumatic
traumatic
encephalopathy.
encephalopathy. Yeah, CT.
That really is, again, it's a function of glycine deficiency.
Mm,
Um, and, I've seen a couple of other cases. I mean, I had another head injury a few years after that. Um, and then I know I had a niece who used to play hockey,
mm,
and she was about all of 4'10". I
mm.
think the uniform, the equipment weighed more than she
Yes,
did, but she
yeah,
loved to play hockey.
yeah,
She loved
yeah.
skating around, and
She got knocked around a
after
bit.
after she graduated college, she was in an adult hockey league, or amateur
Mm,
league,
good.
and she really got clocked on the head with a puck, and that was the end of that. But then she had a concussion, and she would get headaches and dizzy
Mm,
spells, a little double vision or something like
mm,
that after that. And I said, hey, you really ought to try and take this
Yeah.
sweetamine,
Yeah.
this glycine every day.
So
She
there's a
started doing that,
protective.
and that went away. So I think that's one kind of thing, from
Yeah. Yeah.
chronic
Yeah.
or even acute brain injury.
Mm,
It again, just like the injury in the interior of your arteries or whatever, it
mm,
just heals if you have
mm,
enough glycine around.
mhm,
So as now, as far as you say mood and so on, there's a lot of buzz about glycine because of its effect on sleep. So
mm,
glycine is also known as a as an inhibitory neurotransmitter in the central nervous system. And more recent studies, maybe studies that are within the last 10 years, I think, or so, have shown that it works mainly via the so-called NMDA receptor rather than the glycine receptor. So what are those? The glycine receptor and the NMDA receptors, those are brain receptors, which are also gated channels.
mm,
So the glycine receptor, which is there on the macrophages and is important in inflammation, is also the same glycine receptor that works in the central nervous system to help to
mm.
slow
Okay.
down impulses, to
Mhm,
sort of calm things down. So we know sort of how it does. So so many people will buy glycine, will take glycine supplements in order to help them sleep. And many of my own customers will take it in the evening, and it doesn't make you sleepy, but it can, if it's time to go to sleep, it'll help let you go to sleep. And what it does is it can actually lower your core temperature
mhm.
and and provide the basis for like a deep sleep and what they
The
call
deep sleep
non-REM
impact
sleep.
rather than light
And
sleep.
so
Yeah.
it does help with that. And the mechanisms have been worked out
Mm,
pretty much in rodents as to how it does
mm,
it. So, and that does it through the NMDA receptor, as opposed to the quote classical glycine receptor, which is the one that's
mm,
important in inflammation. So even working on these receptors, glycine interacts with a couple of different ones in different ways.
mhm. Gee,
So that's important in the brain,
yeah,
and people know
yeah,
about that for sleep.
yeah.
There's even one Ajinomoto, which is a big amino acid
Mm,
manufacturing company in Japan.
yeah.
They sell a product called Glycom, which is basically little stick packs of glycine, similar
Mhm,
to what I sell for
yeah.
a similar price, only they only give you 3 grams instead of 8 grams. So it's a lot more expensive, but
Yeah. You mentioned like the average person would need maybe 8 to 10 grams of
yeah,
glycine a day.
right.
So are there any conditions, maybe chronic conditions or lifestyle habits that would cause a need for more than that?
Sometimes, because I know I have had the experience with customers who say that, I have a feeling I'm looking at the screen and I see the the left side of my face is kind of beginning to fade away because we had a very overcast, rainy day, and I think the sun is trying to come out, so the sky's getting brighter.
I see
So
it's
my
brighter on your
natural
left side.
lighting is starting to go a little,
Yeah,
you
yeah.
know.
Your left side is
Anyway,
nice and
it's
bright.
just my
Yeah.
halo, that's
Yeah.
all. That's what it is, just starting to shine there.
Hmm.
But um,
The need for more glycine.
one customer I remember came up to me and I don't know, about 10 years ago, and she said, would it be okay to take more? And I said, yeah, it's very, very safe. You can take as much as you want. And she had, I think, plantar fasciitis that was bothering her. She
Hmm.
said, yeah, one packet, 8 grams, seemed to help a little. But then she tried two. She had two really did the trick.
Hmm.
So for some people, occasionally, yes. So one
Hmm.
one customer said to me, she said, "Oh, so if I have this problem, should I take two then?" And I said, "Well, that'd be good for business. If I tell you to take two and it works for you, you'll keep taking two and you'll buy twice as much. Well, most likely, you'll probably only need one,
Hmm.
you know.
Hmm.
Some people even take a half and they
Uh-huh.
find it's enough. It depends on your metabolism, how
Sure,
quickly it cycles
sure.
through you, but
Yeah.
8 is a good one size fits all because you need about 10 grams a day and you get about two or three from a typical
Mm.
diet.
Typical diet.
The
Sure.
other thing is that the way the diet works is that it depends what the diet is. Because remember I talked about that other amino acid, methionine. Well,
Hmm.
methionine is very high in muscle meats. and very low in, like, gelatin from the bones and connective tissues,
Mm.
whereas glycine is very low in muscle meats, but very high in the connective tissues and bones. That's one reason why most people are glycine deficient these days, more than they used to be.
Mm.
Because I don't care what culture you come from, your grandma never threw the bones in the trash. She threw them in
Mm.
the soup, right? No,
Mm.
they didn't throw
Sure.
away any
Okay.
food, any
Yeah.
part of the animal. It was nose
Yeah.
to tail eating
Yeah.
whenever you had meat, fish, poultry, whatever.
Mm.
And so that gave a balance.
To
And
reduce.
so it's
Mhm.
actually been documented. There was a study that was done in 2015, I think, in Oxford University, where they were just looking at amino acids. And they wanted to see if you ate more of certain amino acids, would you also get more of those amino acids showing up in your blood? They were looking to correlate intake of amino acids with the amount of amino acids in your blood plasma.
Mhm.
And so they found that it pretty much worked out if you ate more histidine, because they took 100, 100 vegans, 100 vegetarians, 100 meat eaters, and 100 fish eaters. And they looked at all their at the amino acids in their diet every day, and they looked at the amino acids in their free amino acids in their blood plasma.
Mhm.
And they found generally a very good correlation. If you ate more histidine, you had more in your blood. You ate more lysine, you had more lysine in your blood, and
Mhm.
so on. But then it didn't work out for glycine. That
Mhm.
was the one outlier. Why?
Mhm.
Because the meat eaters had the least glycine in their blood, and the vegans had the most, even though the meat eaters, because meat is so high in protein that even if it just about any kind of protein, if you're a meat eater, that is an omnivore, you eat meat, fish, poultry, all of those things, dairy. If you eat that kind of a diet, you're going to have more intake of all the amino acids, including glycine, but they're not going
Mhm.
to be in balance.
Oh, so it's
So
going to
it
be a
turns
smaller
out that the meat
percentage.
eaters had less glycine. So that's
Smaller.
one of the reasons
Oh.
why we are so deficient now.
Oh. Okay. It's a smaller percentage of the total amino
That's
acid.
right, right. The balance is off. So
Yeah.
if you eat glycine
Uh-huh.
poor protein, even though it's got plenty of glycine in it, but relatively speaking, it's got less glycine in it. You're going to have less glycine if you eat that kind of protein, because the more methionine needs to use up some of the glycine to clear it. That's the
Mhm.
other caveat here, is that when you eat too much methionine, even though that's essential, we eat far more than we need. So when you eat too much glycine in the hour after you eat that cheeseburger, your liver is not doing the recycling that we all learned
Mhm.
in biochemistry class about the
Mhm.
methionine cycle, how the body recycles this key amino acid,
Uh-huh.
methionine. After an hour after you've eaten that cheeseburger, your liver is busy getting rid of it as fast as it can because it has far too much. But for every molecule of methionine it needs to get rid of, it needs to use up 2 molecules of glycine.
Oh, wow. Mm.
So that's what we found in our experiments,
Mm.
really. Ultimately, that was the right answer,
Yeah. Yeah.
was that the excess feeding an excess of glycine protected the body from the stripping of glycine that the methionine otherwise would
Mm.
cause.
Mm. Mm.
So very
Yeah, it gives it
interesting.
more. So it's like,
Meanwhile, speaking of not drawing the right conclusions, the Oxford people had no idea
uh,
why they couldn't explain it. They couldn't
uh,
explain their finding that the reason why meat eaters had less glycine in their blood.
mm.
Couldn't explain it, but it's
Yeah, it's
very
like,
simple,
okay.
The two things are too
Yeah.
specialized these
Yeah.
days. And they were amino acid people. They weren't aging people. They weren't biochemists. They were,
Mm.
they had their little lane, which was, oh, how much of this and how much of that? Why is it? And then, because you have to understand with that research these days is now leaning on a lot of these tools called omics.
Oh,
So they
what are
have
they
a tool,
called?
omics,
Hummocks.
omics,
Okay.
metabolomics, genomics, lipomics, where they will look at every gene or every gene product or every protein or every metabolite. So they were doing a metabolomic study
Mm.
where you can take a drop of blood and measure like 300 or 400 different things in it.
Oh, wow.
So now, in the old days, you couldn't do that. So, but now they do what is called data-based research. They collect enormous amounts of data, and
Mm.
then they publish all the results there. They put it down in their
Yeah.
paper, and they let the computer
Yeah.
decide what's significant, what isn't significant. They do
Sure.
what they call heat maps, just to show what's different between, let's say, cases and controls in a study. So they're basically throwing the data up against the wall to see what's going to stick. And then they'll spend their discussion section of the paper. Usually that's about half the words in a paper are the discussion, which is where you actually interpret what you found.
Uh,
And then they would speculate, well, it might be this and it might be that because glycine does this and glycine does that and glycine does so many other things. And they were speculating all over the place. Meanwhile, the reciprocal relationship between glycine and methionine had been in the literature for years, but
mm,
they just didn't know it. So it's very, very compartmentalized. And, in the old days, we used to do what is now called hypothesis-based research.
yeah,
And we used to just call it science.
yeah, yeah.
Nowadays, what they call database science, we used to call a fishing expedition.
Mm,
Right? You could never do it. Nobody could afford to fund a fishing
mm,
expedition where you measure hundreds of different
yeah.
things because you couldn't do it. You can only measure a few things. So you better have a pretty darn good reason
Mm,
for
mm,
looking for what you were looking for if you want to
yeah.
get that grant and do that
No,
study.
hypothesis. Yeah, now we have massive databases, right, with all the data that's poured into
Right.
them, and we
Now we
can.
got to build data centers, and now we got most of the energy generation in the country
Yeah,
has to feed data
yeah, sure.
centers. And most of
One
the
more,
data is probably garbage.
one more question before we break. But collagen has become a huge topic in wellness and longevity.
Right.
How does that interact with the
Well,
whole?
collagen, as I said, is the main protein that you have in the bones and the connective tissues,
Mm,
right? So if you get gelatin is basically denatured collagen. Collagen peptides, partially digested so that it's soluble enough for your digestive system to handle it. So in fact, collagen or gelatin is approximately 25% glycine by weight.
mm,
So that's a good source of glycine, and that's why it does you so much good. People say, "Oh, it's if you eat collagen, it's because your collagen deteriorates because you make less, and this enables you to make more collagen, and that's why it's good for you." No, or you have to have special type C collagen or type 2A collagen, and if
mm,
somebody's selling you a more expensive kind of collagen, no,
yeah.
they all have about the same amount of glycine, and it's the glycine that is important. And by the way, that's not speculation. That's really an important scientific principle. If you have, let's take chicken soup, which also is a way, chicken soup. Has there been studies on chicken soup to show that yes, it helps you get well when you're ill and so forth. Why? Because that's bone broth.
Mm,
It has a lot of glycine in it
mm,
because it has collagen in it. Well, but bone broth has so many things. Collagen has so many things, other amino acids. How do you know it's just the glycine and not the combination of that and or anything else? And the answer is if you can get the same benefit from pure glycine, then you know it's the glycine. You have to reject unnecessary
mm,
hypotheses. So,
mm,
for example, one of the questions that I tend to get from a lot of skeptics is, "Oh, come on! You say glycine is like a cure-all. It's glycine that does this and glycine that does that, and why is it all glycine, just the glycine and not something else?" And that's because that's the simplest explanation. It's just the glycine.
mm,
You want to look for that one thing
mm,
that is responsible for all those effects. That's a principle called Occam's razor.
mm,
That's a scientific principle. It was articulated by a number of people in history, but
yeah.
one of them was John of Occam. It was something like the 11th century, something like that. And it's basically saying that the simplest hypothesis is the one you have to accept.
Mm,
So people say it can't just be the glycine. That's too simple.
uh,
The scientific principle is you don't reject a hypothesis because it's too simple. You reject a hypothesis because it's too complicated.
mm,
That's why we accepted the
yeah,
Copernican model of
yeah.
all the planets revolving around the sun in simple elliptical orbits rather than all the planets and
All
the
the
sun
complicated. Yeah,
revolving around the
yeah,
Earth in these
yeah,
complex
yeah,
epicycles.
yeah,
Too complicated.
yeah, yeah,
Can't be right. The
yeah,
right one is the simple answer.
yeah. Yeah, so glycine is really present in so many of these physical systems in our body. I mean, that's
But
important to know.
its particular role in inflammation is the one that stands out the most. It's the
Yeah,
one that's
yeah,
most
yeah, yeah,
obvious,
yeah,
that produces the most
yeah,
ill effects.
yeah.
In our otherwise long-lived population, things that
Mm,
show up
mm,
after decades of life.
mm,
And glycine was always, I'm sure, an essential amino acid. You had to have some.
mm,
But it's much more critical nowadays for a couple of reasons. One is we tend to throw the bones in the trash instead of the soup.
mm,
Another thing is that we eat too much methionine, too much muscle meat, so we end up having to get rid of it. So we end up stripping methionine that way.
mm,
And the
mm,
third thing is that we eat so much of everything, guess what? Everybody's fat.
mhm,
More recent research also shows that when you get obese, even the kids, this was some studies done on obese kids at the Mayo Clinic in just a few years ago, that when you're obese, the liver's synthesis of glycine actually goes down.
mm,
So you're not only,
mm,
using up glycine, taking
mm,
in more methionine, which strips glycine, not eating the glycine, but
mm,
even the glycine that your body making, it's
mm.
making less and
It
less.
gets
And it
reduced.
makes
Wow,
less and less with age too.
wow, yeah, wow.
So
Well, we
it's,
could go on.
oh, we could, I
We could go on.
could.
I
Yes, I
thank
could.
you.
That's why we have to do different shows.
Yeah, yeah. Yeah, this is great. Thanks so much for returning. This is the follow-up conversation that I really wanted to have. So, tell us about your website and where our
Oh,
listeners
yes.
can hear more
So,
about your work and your products.
oh yeah, well, I have another product. Another product is a book called The Glycine Miracle,
Hmm.
which it's just if you just search on Amazon my name or glycine, you'll scroll down, you'll find the Glycine Miracle, and
Great.
it's
Okay.
that's available at Amazon. I don't sell that on my website because on my website I only sell Sweetamine because that's food, and so
Hmm.
it's taxed differently, right? So if you want to get the book, get it from Amazon. You can find a link on the website, but
Sure.
that link will take you to Amazon. Not to
Okay.
give a plug for Amazon, I'm just plugging my own
No, I
book.
understand. Yeah, it's easier.
Anyway, the other thing is the
Keep it
product
simple,
itself,
right?
of course, you can buy off the website, sweetamine.com.
Uh-huh.
Sweetamine, SWEETAMINE.com. Or if you want to call up and speak to
Mhm.
Dave, my wonderful customer service representative,
Sure.
who's also the IT guy. So if something doesn't work, like if you try to order it off the website and it
Oh,
doesn't work, and you get frustrated because your card keeps getting declined or something, you call him.
he can answer it.
He'll
Okay.
he'll explain it to you. So and he'll get the order process. So that
And
you
how
can
are
just
the
call 1-855 get sweet, right? 855 get sweet, and you can do that. And you know
good?
that's the easy way to do it.
How is it sold in packets of what?
Yeah, well, it's sold in boxes. Like if you have
Hmm.
okay,
Okay.
I don't know if this is going to focus or not.
It doesn't focus. Yeah,
Yeah,
pull it back
something
a little
like
bit.
that,
Yeah.
right? It's a box of sweet. I mean, that's a box that has 30 stick packs in it, so it's a month's supply. And so that's a month, that's a box. But if you just want to try it
Mm.
for less than 20 bucks for 19.95, you can
Uh-huh.
just get a sample, what we call a 12-day challenge. It's enough to try it for a few days,
Okay.
go off it for a few days, try it again, convince yourself that it really is the sweetamine that's doing the
Mm.
trick. And that either way, whether you buy a 12-day challenge or a box,
Mm.
number one, we're not going to sell you any more. You're not going to start getting more orders or
Mm.
more billings or anything
Mm.
like that. You
Okay.
buy it. If you want it, you buy it, put your credit card
Not
number
a
in, buy
subscription.
it.
Yeah. Okay.
But it's risk-free.
Hmm.
So if you try it for a month or you try your 12 days and you say, I don't like it. I don't like the taste. I don't like whatever it is. That
Yeah.
you don't need a reason. You just say, I want my
Yeah.
money back. We'll give you your money back. You don't have to send us the
Sure.
empty box
Good
or
to
the
know.
empty packets.
That's
Just
reassuring.
tell us you want. That's risk-free. I always want it to be risk-free, but you got to pony up a little bit at the beginning
Of
because I've
course.
found that if you don't make people put in a little at the beginning, they
Mm.
won't value it.
Yeah.
So at the beginning, I thought, oh, I gotta spend a lot of money on product just to give it away for free, but I don't give it away for free.
No.
I
No.
give it
It's
away
not
for
good.
free only if I'm, if I'm doing a presentation to a small group, you
Hmm.
know, or I get a chance to talk to somebody one-on-one, you
Sure.
know. I think I sent you a box. If I didn't send you a box, tell me I'll
No.
send you a box
No, you
because
didn't. I would love that.
I know you'll take it.
Yeah. Of course.
But
The
that's
packets
why
are,
I want to make sure they're going to take it. If you just say,
yeah,
try your box for free, people say, oh, yeah, it's free. I'll take 10 of these, and you'll never try it
you said
because you don't value
36.
it if it's free. So you want you to put up at least $20,
Of course.
1995
Yeah.
to
Yeah.
start with,
I'm
and you can
trying to get
get
an
that
idea of the
back if you don't like
packet
it.
size, Joel. The packet, 36 packets in a box?
30 is
30.
a month,
And
yeah.
how many grams are the packets?
Well, it's 8 grams of glycine.
8
Yeah.
grams.
It's
Okay.
also got some taurine in it
Okay.
and.
Okay. And your
Uh,
website is sweetamine.com, and
Sweetamine.com.
the number is 855 get sweet.
Yeah.
And well, that's great. That's
Okay.
great. Yeah.
See you
Yeah.
in another 100 years, or maybe
Yeah.
soon. I don't know.
Well, let me just wrap up for my audience. Thanks so much for joining us today. If our conversation gives you something to think about, you'll find more ideas, tools, and discussion at my livingto100.club website. And I also have a livingto100.community where people can join for purpose and interactions and coming together in a community forum. So thanks very much to all of our listeners, and thank you, Dr. Brind, for being back on our program. Valuable information. I know our listeners will enjoy this a lot. Thanks so much. And thanks to all of our
Okay.
listeners. Hope to see you next time.